When a number is raised to a power, the number is multiplied by itself. So 5 to the 4th, we did this last lesson, means 5 fours. 4 5s. Okay?
Mm-hmm.
The opposite of raising a number to a root is finding the root. No, excuse me. The opposite of raising a number to a power is finding the root of a number, which is breaking it down into its equal factors. Following several examples. The square root. The square root, and I'm going to stop reading for a moment. The square root looks like this, and it has no number on the side, and it really means what number multiplied by itself. So if I picked a number like 25 and I said, what number
5
squared gives you 25, and that is 5, okay? And it's true because 5 squared equals 25, okay? So that's why we call it a square root, because root is the backwards of a square,
right.
Okay? So if we do cube root, we write it like this, but we could have put a 3 there, because the one without it means a cube, square, what the 3 means a cube. So if I come in here and I go 27, and I say what multiplied by itself 3 times gives me 27, that will be
9? No. 3.
Yes, because 3 to the 3rd power is 27.
Right.
That makes sense?
Mm-hmm.
So if we do a 4th root, now we had a cube, we had square and cube, they have special names, but 4th, 5th, 6th, 7th, we just put a th at the end, and so we don't have a special word for it, but square and cube we do.
Mm-hmm.
And so if I have a 4th root of, I don't know, we'll try 81, and I know the answer to that one, and I'll just tell you. You'll memorize that one eventually. But the 4th root of 81 is 3, because 3 to the 4th power is 81.
Oh, yeah, okay. It's 3 times 3.
3 times 3 times 3, okay? And they're going to do one more. They're going to do a 5th root, and we can just keep going on and on and on and on. A 5th root, we just keep doing that. We put a little 5 there. And a 5th root, we could do that of, they say 100,000 there?
Oh, right.
A 5th root of 100,000 is 10. Because 10
Oh, yeah.
to the 5th power, and that has 5 zeros,
Zeros,
so that
yeah.
would make sense. 1, 2, 3, 4, 5.
Got it.
And so we can have bunches of like that, okay? And they want to tell you the pieces of all these things so that you can kind of, if you ever had a book that was telling you these, you'd know your vocabulary words, okay? So if I had a cube root of 27, this right over here, your number is called your index. And this thing here is called your radical sign, and it doesn't matter if that's a square root or a cube root or anything. This is always called the radical sign. And usually we just shorten it and call it the radical. And if someone actually, in a moment, I'm going to use the word just plain old radical, and if I don't have an index that I tell you it's the 3rd root or the 4th root, you automatically assume that it's the 2nd. It's just a square root.
Okay.
This thing that's under here, since that's called a radical, this is called a radicand.
Yeah.
All right. So, if I wanted to find, I could just call this radical 25.
Okay.
And I don't know, if you ever put an index up there, it's automatically, then I don't think you call it radical anything, you would call it the cube root or the 4th root or the 5th root. Okay?
Okay.
All right? And so, we got to talk about negatives too. We'll do that in a minute. I'm going to read this little box here though. It says, although 3 squared is 9, negative 3 squared is also 9, you might conclude that the square root of 9 can be 3 or negative 3, okay? However, the square root refers only to the positive or principal root. So if they ever ask you just plain old square root, you give it the principal or main one. You do not need to give the negative one. We'll talk about when you do give the negative one later when we're solving equations, but for right now, if they ask you for the square root, they mean the positive one. But if they do this, and they say this,
then you give
them the negative one.
Okay.
So if they just give you a radical, they just want the positive answer.
Okay.
Okay. All right. Now we're going to talk about problems, or not problems, but negatives, okay? Okay. So if I had the cube root of negative 8, that means what times what times what gives you negative 8?
Two times 2 times 2, but 2 would be negative and 1 would be positive. Right?
And it has to be the same.
2 would be positive and 1. No, but it has to be the same.
It does.
So then what?
So if I just write your 2 times 2 times 2, because we're just thinking, okay, that's not the answer yet. Oh, actually, let me just do it this way. We're brainstorming here. 2, 2, 2, okay? Positive, positive, positive gives you positive. But how can I make it a negative? Because if I just did 2 of them, which is not allowed really, it'd still be positive.
You did 2 positives and 1 negative.
Yeah. If I did 2 positives and a negative, that would do it. But they all have to be the same.
So
They either have to be all positive or they all have to be all negative. Which is it?
you could do them all negative.
If they're all negative, negative times
It would
negative.
still be negative.
Yes, so it's negative 2. Okay?
Got it.
Okay. So cube roots, we can do negatives. Okay?
Okay.
That's okay. Let's do the cube root, and I'm going to actually let you look at this thing that you're going to memorize. So you're going to write them down anyway, of negative 125.
Wait, hold on. Where is it? Is it like right here?
It's in the cubes.
Oh, okay. So
So
if it's already if it's negative inside, so negative 5.
and you not necessarily even need to worry about this part. Over here, you know that the cube root of 5 is, not the cube root.
So if it's already negative, you just make it that.
Yes, you just make it negative. You know that 5 cubed is 125. So negative 5 cubed will also be negative 125.
Okay.
Does that make sense?
Yeah.
Okay. So let's talk about square roots now and negatives. So we know that the square root of 4 is 2, right?
Mm-hmm.
What's the square root of negative 4?
Negative 2.
So if it's negative 2
No,
times
it'd be
negative 2,
positive 2 because 2 negatives makes it positive.
yeah, so if I did 2 times 2, then this becomes 4, and this becomes 4.
Right.
And they have to be the same. We can't make one negative and not one. Okay, does that make sense?
Yeah.
So what is the square root of negative 4?
2.
No, because 2 times 2 is positive 4.
No. Oh, okay. Great. Okay. Because is it a null set?
It's null set. Fantastic. Not possible at all. You will eventually, when you get to Algebra 2, learn that they make up, in a sense, but it's something useful in the world. But they call it called an imaginary number. It sounds terrible right now, but they call anything an imaginary thing, as if it wasn't real. But it has a use in real life. But right now, for your purpose, if they ever took the square root of a negative, it's not possible.
Oh, okay.
Okay.
Because I was like,
All right.
I cannot think of any other
Exactly.
way to do that.
So if I did the square root of negative x,
It's not possible.
it's not possible, or null set. Okay?
Okay.
All right. And so that's what you're going to do here. You're going to just take square roots of
Okay.
various things and cube roots of various things. So, and it works the same for fourth roots, by the way, of negatives. It's still the null set. But the fifth roots of negatives are possible.
Because
Okay.
it still makes sense because the even ones are going to be null sets and the odd ones aren't.
Very good. That's right. So this is possible. Whatever this is, we don't know because it's an x, but this is possible.
Okay.
Okay? Then even ones are not possible, you're right, and odd ones are.
Okay.
Okay? And so,
Then they have the...
and then we have some fractions. Fantastic. So let's do that. So if I had, let's do 25 over 81. Okay?
3 goes in.
Do you know what the square root of 25 is?
5.
Okay. Do you know what the square root of 81 is?
3.
Careful.
Wait. 9.
Very good. That
I don't know
is
why I said
the
3.
answer.
Oh, that's
Okay,
it?
that's it.
Oh.
Just take the square root of the numerator and square root of the denominator, and you're done.
Oh.
Okay?
That's
No
not
big
hard.
deal. Okay? And now, yeah, that works too. If I could have done lots of them that way, I can do 1 over 100. What's the square root of 1?
1.
Very good. Square root of 100?
10.
10.
Okay, that's not hard at all.
Not hard at all.
No.
Okay? Okay. So you've just done, we talked about different, we have square roots, cube roots, fourth roots, fifth roots.
Yep.
We know that some of them you can have negatives and some can't. Which one can have the negatives in them? Under the radicals.
The cubes.
The
right?
cubes and the
And the fifths.
fifths and all odds.
And
Very
all
good.
odds.
And when you're taking a square root, and I say a 4, technically, I could write 2 and negative 2, but they don't want us to. They only want us to give which one?
The positive.
The positive, so we don't need to give the negative. When we're
Okay.
later, when we solve equations, we will, but right now we won't. Okay?
Okay.
All right? We're done.